Find an equation of the tangent line to the function f of x at the point pi over 4 and square root 2. So let's look at the graph of cosine x but with an amplitude of 2, and at pi over 4 where we want to find the equation of this tangent line to the curve. The first thing we're going to need to do then is find the slope of that line, and we know that is the limit as h approaches 0 of this function at a, which our a is pi over 4 plus h, so that's going to be 2 cosine of pi over 4 plus h minus the function at a, which would be 2 cosine pi over 4 all over h. Right here we see we have the cosine of a sum, so we need to remember the sum formula for cosine from trig. That was cosine of alpha plus beta equals cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. So applying that to our problem here, we have the limit as h approaches 0 of 2 times the cosine of pi over 4 cosine of h minus the sine at pi over 4 sine of h, and then we still have minus 2. We can go ahead and work the cosine of pi over 4, that's square root 2 over 2, and then all of that over h. Now we can do a little bit of simplifying. These will reduce, and we know that the cosine of pi over 4 is square root 2 over 2, and we know the sine of pi over 4 is also square root 2 over 2, and then this 2 that's out in front applied to each of these would cancel with these denominators. So let's write down what we have left. The limit as h approaches 0 of square root of 2 cosine h minus square root of 2 sine h minus square root of 2 all over h. Now I'm going to take this first term and this last term, and I'm going to factor out the common square root 2. That'll leave cosine h, whoops, looks like we got a double h in there, minus 1 over h, and then we have a difference here, so the limit of a difference, we could take the difference of the limits of the two parts, and so this is h goes to 0 of square root 2 sine h over h. Now I have the limit of a constant multiplied by this function, so I can take this square root 2 and multiply it out in front in both places. And then we've got to remember something we learned earlier. The limit as h approaches 0 of cosine h minus 1 over h was 0, and the limit as h approaches 0 of sine h over h was 1. So this will be gone, and the rest of this will leave us negative square root 2. So we have found the slope of the tangent to the curve at pi over 4, and it's negative square root 2. We're ready to find the equation of the tangent to the curve if we remember the point slope formula. And then we can go ahead, here's our x1 and here's our y1. So we have y minus the y from the point, which is square root 2, equals the slope. We just found that, negative square root 2 times x minus the x from the point, which is pi over 4. So solving this for y, we have y equals negative square root 2x plus square root 2 pi over 4, and then moving this term to the other side, plus square root 2. So here's our equation of the line tangent to this function at a equals pi over 4.